Hey everybody, this is Larry. This is me doing the daily Leetcode challenge, day 25 of January 25th. I don't know why I'm saying it that way. Day 25 of the January Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, show me some love and all this other stuff. Today's problem is 2359. Find closest node to given two nodes. Okay, so you're given a directed graph. At most one outgoing edge. So it could still have a cycle, so it's not a DAG, right? Unless I misunderstood it. Yeah, okay, they even tell you. I just want to make sure. So, okay, the graph is represented with a zero index edges, so you're given an edge list. Oh, no, you're not given an edge list. You're basically given, because each node could have one edge. I think this, I forgot what Josh tell me. Was it like foundation graph or something? I forget what it's called. That's not it. It's like frontier graph. No, what was that thing? I forget. So I'll ask Josh later. But apparently there's like a thing where each node has one outgoing edge. There's like a functional, maybe functional. Let me think. I guess a function graph. I don't know. The functional graph makes sense because in a way you're kind of mapping A to F sub A or something like that, right? Or F of A or whatever. But anyway, it's not that important. I'm just kind of going through my knowledge here. Okay, so basically you're given a list of edges and what they connect to, except for if it's -1, and then you're given node 1, node 2, and now we're trying to find a node that is connected to both of them. Okay, I don't. Seems pretty straightforward in the sense that, I mean, I think I don't know. Let me know if this is reasonable, because I think sometimes I try to think about like what would a beginner think, so that I could explain the problem that way. But sometimes I think I dumb it up a little bit too much. So I don't know. Let me know in the comments which direction you think that's true. But oh, actually, I've also forgot to check to see if I get extra. Oh, sometimes they give you extra Leetcoin or whatever it's called, Leetcode coin. I don't know whatever the coins are called. But anyway, so yeah, so this one, maybe the naive thing would be like, okay, to test each node and then see what's the distance from to node 1, node 2. But of course, if you do that for n nodes, that's going to be a little bit slow. But here it seems like you can actually just such that the maximum and the node 2 to that node is minimized. Okay, I mean that's just maximize the difference. That's really awkward. But in any case, because there are only two nodes that you have to worry about, and you know that you can visit the shortest path in linear time, O of v plus e, where e in this case is just clearly O of v. So that means that you could just run two depth first search, or breadth first search. Doesn't really. Am I lying? I think I may be lying. I think you need a breadth first search. Yeah. Okay. Yeah. So you have the maximum between the distance from and from the node is minimized. Say what? Let me read this again. Maybe I missed, but I think you still want the shortest path, and if you want the shortest path, then this should be relatively max between the distance and from. I think they. This is a reading hell, but I think they mean that. That means that the delta of the delta between the two distances are minimized. I think that's what they're saying, but it's very awkward phrasing. But yeah, but what we're gonna do is do a breadth first search. So let's do it. And you know, a lot of these times, I think that's why having a good understanding of breadth first search, which obviously is a very kind of a fundamental ground unit of knowledge that you need to do for interviews. So yeah, because, and why I said that is because this edge is given in a to be honest, a sort of a a weird or a not as common representation, but that's okay. If you have a strong breadth of search, then we'll figure it out. And because we know we have to write breadth of search, we have to do 2 breadth of search. So I'm just gonna write it as like begin by writing it as a function. So then we can kind of just return the results afterwards, right? So then maybe like I have distances is equal to say none times n, right? And then the distance of start is equal to 0. Q dot append of start, and you may wonder what is Q? Q is the collections dot deck, right? And then while length of Q is greater than 0, and this is very standard breadth first search. Actually, what am I talking about? You don't even. I think depth first search also works because this is a functional graph. I forgot about that, where you only have one outgoing edge, so there's only one way you can go, right? And you either visit all the nodes or you don't. I don't know, but I'm so yeah. So I retract what I said because for some reason in my mind I had a graph that had 2 outgoing edges, which is obviously not this problem. But yeah, if you already know how to do with breadth first search, do with depth first search. If you know how to do with depth first search, do with breadth first search. It's not that big of a deal either way. Though I think for me, I think depth first search would have been shorter to write, but it's not really it's not really a big deal. And then now we want to do distances of edge sub x, right? Is equal to d plus 1, and then q dot append edge sub x, and then that's pretty much it. And then we just return distances in the end, and you can do this like I said in breadth first search, depth first search, whatever you like, maybe even low first search, right? So you have d1 is equal to breadth first search from node 1, d2 is equal to breadth first search of node 2, and then return the node of the smallest index. So then maybe we return -1 if nothing happens. But I'm still the maximum of those. Oh, not even the distance. Okay, so I think in the examples they actually clear up what they meant. I thought they mean the maximum of the delta of the 2 distances, but it seems like we just want the max of the 2 distances. So that's fine. That's easy. Yeah, and maybe here instead of writing none. Also, I made a mistake here. See if you could spot it before I kind of correct it. And I will correct it now. I kind of made a mistake because I did not check that, and this was going to be an infinite loop, right? Something like that. But I'm actually going to change this to infinity, so that's slightly easier to check for what I'm going to check for now. And then basically for xy in zip of d1, d2, and we actually want to enumerate it so we get the index as well. Right, and then basically, so now the new d is equal to max of xy, right? If d is not equal to infinity, that means that both of them are not unreachable. That's where we do infinity. Then we want to take the max of it, and then we just want to keep the best, right? So let's just say best is equal to, what is it, -1? Do we want it to be -1? No, we want best to be, we want the minimized of the max. Okay, then best is if best is greater than d, then best is equal to d. We also need to keep track of the index. So maybe we do it as -1, and then best I is equal to index. If the multiple answer of the smallest index, so that should take care of it because we handle it in order. And then at the end, we just return best of I. And maybe for slight readability different, we can just do it this way. But man, what am I doing? Maybe I misunderstood this. Well, it is easy to kind of just debug maybe whether it is part 1 or part 2. So yeah, so 0 from 0 to 2, did I mess something up? Because basically we didn't do anything here. Oh, whoops! This is a typo. I meant edges of X, of course. All right, there we go. I fixed my bug by introducing another bug. All right, let's give it a submit. Uh-oh. Oh no, there we go. But yeah, as I said, 10:30. Yay. A little bit on the slower side, maybe. Oh no, I don't think I could do it that much faster. I mean, maybe you can do something like doing it concurrently and then maybe return early, but I don't think that's really worth the complexity. I don't think I do anything psycho-y. I don't know, but yeah, but this is gonna be, like I said, this is going to be the lower bound of linear time and linear space. The linear space comes on the breadth first search and kind of going for the distance. Can't really avoid it for a breadth first search or depth first search, really. I guess the depth first search might have been a little bit faster. But yeah, but this is v plus e, where e is v or less. So this is going to be O of v, and O of v is O of n, maybe if you want to say it that way, which is linear time and linear space. I don't not going in, I'm not doing a strict proof like I usually may do, because this is just breadth first search, pretty standard. And this is also breadth first search. I mean, two breadth first search and a for loop. I hope I don't have to explain it that in line by line. Let me know what you think. Yeah, let me see what I did last time. This was only 6 months ago. So was this a recent contest? Is this the previous one? Wow, my old code looks almost exactly the same, like I copy and pasted, really. I even used Infinity. Except for, in that time I created this thing. Maybe I was just lazy with the edge list. But I mean, you don't have to, but you could, I guess. But this thing even looks, I guess, the same idea. Cool. That's all I have with this one. Let me know what you think. Let me know how you did. Yeah, stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.